Hi there, welcome to my channel. If you're a returning viewer, you would know that in this channel, I'm not only teaching you what the solution to a HackerRank problem is, but I'm also trying to show you how to think about the problem. What is the rationale? What is the logic that helps you to tackle this problem? Not only this problem, these types of small bite-sized solutions and reasoning will help you tackle bigger problems within the tech industry. And if you are a new viewer, welcome to my channel. I am honored here to be bombarded with a lot of great comments from everyone telling me that I'm doing a good job. So if you like my videos, please subscribe to my channel, share it with your friends, and let's jump into this one. This problem is called Triangle Quest. This is a sequel of another Triangle Quest number 2 that I've already solved. I've left the link up the top right. This is my routine. I leave Hackerrank on the left-hand side. I read the problem from there and explain it to you. And I've got a Jupyter notebook on the right-hand side, which I use to explain the problem to you. Let's see what Triangle Quest is about. I'll just extend my HackerRank window. You are given a positive integer n. That n can be anything. It's a positive integer. It can be number 2, number 7, number 155. Print a numerical triangle of height n minus 1. So for example, if the user gives us 5, we need a triangle of height 4, like the link below. So you can see that number 1, then 22, then 333, and such and such. Now we need to think, how do we use what user gives us, which is a number like this one? For example, here the user has given us 5, to create something like this. Let's do it step by step. Here are the conditions. Can you do it using only arithmetic operations, a single for loop, and print statement? So can we do it in one line? Yes, we can, but I will show you how to tackle this. Then I'll show you how to make this into a one-line code. Use no more than 2 lines. The first line, the for statement, is already written for you. I can't see it here written for me, but it's okay. I can figure that out. You have to complete the print statement. So we will be doing the print statement. And using anything related to strings will give a score of 0. So we can't use anything related to strings. All we need to use is arithmetic operations. Essentially, we need to use math. We can't print 1 and 2 right next to 2 using strings. We have to do some math and produce it. I'll make my Jupyter lab a bit bigger. And I will scroll down for you to see what the user will give me. The user will give me a number. So let's do that. Let's accept an input from the user. So I can say n equals, that comes from an input function. Haven't seen my video on the input function? The link is up the top right. When that comes through, we know that the input function gives us a string format. So what we need to do is to convert it to an integer. Otherwise, we can't do math on strings or things that are not numbers. So let's convert that into an integer. Let's run that and give it a 5. And if I print n, you will see that it's a number. So that's number 5. What I can see from the output, here is the output, right? If I show you the output, let's see what kind of rationale can produce this for us. What I can quickly do here is, I think you would agree with me that this is 1 times 1, which equals 1. This one is 11 times 2, which equals 22. This one to me looks like 111 times 3. And I believe you could easily tell now that this one is 4 times 1 times 4. So I can see the pattern right there. All I need to do is to run a for loop that produces these ones, right? And also multiplies by 1, 2, 3, 4, or however many the user gives me. So I'm not going to run this because this is not the right code. Let me just make a new cell and I will start thinking, how do I produce these ones? Because these ones are easy, right? Let me show you why I say these ones are easy. If I write a for loop and I run it from 1 to n, I will try and see, does this produce I? Well, it actually does. It gives me 1, 2, 3, 4. So I've already got that. So that bit is easy. All I need to do now is to find something, and I don't know what that thing is, and say that one times I. Now I will be finding the answer for this bit because this bit is already solved. I know how to do it. For this bit, let's look at them. You've got 1, you've got 11, you've got 111, and you've got 1111. Again, if you want to make it easy for yourself, watch my other video on the triangle quest. But here, I want to separate the problem. I will say, I need something that gives me these figures, right? In order for me to produce those figures, I have to think, what if I run something on the floor division area? If you don't know what a floor division is easily the question of asking how many healthy number 9s can I fit into number 10? Well, you can only have one full and healthy 9 in a 10. How many healthy 9s can I fit into number 100? 11 of them, because 11 times 9 is 99, and then there is 100. What if I think about 1000? How many healthy 9s can I fit into 1000? 111. Can you see that pattern coming up from floor division? I believe what is happening here, let me say this one is for the third one, right? So in the second one, I had this one. So floor division of 100 by 9. This one was 10 floor division by 9. And I'm pretty sure you can tell that the next one is 10,000 floor division by 9. For me to be able to put this into a formula, I think this one would be 10 to the power of 1. This is 10 to the power of 2, which means 10 times 10. This is 10 to the power of 3. And you can see that I am easily again seeing this 1, 2, 3, 4. So eventually what will happen, what if I said this one is 10 raised to the power of I? Let me just run that. I know that it's not correct, but I just want to see if I'm getting there. This one gives me 10, 200, 3,000, 40,000. That's not what I wanted. I wanted to produce this. What if I add the floor division of 9 and let me put all of them into another new set of brackets, and that gives me 1, 2, 2, 3, 3, 3, and 4, 4, 4. I believe that does look like this. I'm pretty sure I'm getting there, but I will have to copy the code into Hackerrank and see if it likes. What I will do, I will only copy across the bits that I think are relevant. So I will need an input, bring the input in. I will copy this for loop and I'll paste it here. Let me extend Hackerrank and run the code, see if it works for the first test. It didn't quite run because more than 2 lines of code is not allowed. I have been asked, I can only do 2 lines of code. So the problem is, right now I need to put this as 1 line, if you like, and this one has to be the second line. What if I do this? Look, this is n, right? N comes from here. So in my code, wherever I see n, I will just put this one in because they're the same. So I'll copy that and I'll put it here. This is the only place I have n. And if I run that again, it will ask me, what is your number? That's 5. And I will see 1, 2, 2, 3, 3, 3, and so forth. So let me copy this because now I can just get rid of the first line. I don't need that. And I just can make it 2 lines. Paste it here and run the code. Let's see if it works. More than 2 lines of code are not allowed. I don't have more than 2 lines of code, but it's probably because Hackerrank thinks that they have already given me something, but they haven't. Let me just restart this. Maybe they're making a mistake. Let me paste that here again, run the code. Coding is all about troubleshooting. Trust me, we're not getting this wrong. It's just the platform wants a very specific thing. So what I will do, I will now then move into a better code. Maybe it will work. All right, what I can do, I'm just gonna trick Hackerrank. So maybe I'll just move this here because I can. I can have my for statement here and the action right after it. It doesn't bother Python. So copy that and come here and place it down here, run code, and let's see if it works. Yep, that one did work. Let's submit the code because there must be, again, some problems with Hackerrank that says, no, I don't like that. Let's submit the code. There are 3 more test cases, 0, 1, and 2. And ta-da! Look at that. That was easy. That was solved. So if you like this video, hit the like button, share it with your friends, and leave me a comment about what you want to see next. Thank you.